Ever wondered how AI can process videos so quickly? It's not just about watching frames, it's about making sense of a massive flood of data. But here's the catch, videos are huge. Every frame is packed with details, and traditional methods struggle to keep up. That's where a game-changing technique called LLaVA-Scissor comes in. Let's break down how it's rewriting the rules of video understanding. Imagine you're watching a 10-minute video. Your brain instantly recognizes objects, actions, and scenes. But for AI, every frame is a sea of tokens, tiny digital pieces of information. Processing all of them is like trying to drink from a fire hose. That's why researchers are racing to find smarter ways to compress this data without losing the story. Enter LLaVA-Scissor. This method doesn't just cut corners. It cleverly trims the data by grouping tokens based on their meaning, not just their position. Think of it like editing a movie. Instead of keeping every shot, you focus on the key scenes. For example, if a video shows a dog running in a park, LLaVA-Scissor identifies the dog, the grass, and the sky as separate semantic regions, and keeps just one token per region. No repeats, no clutter. Here's the magic. It works in two stages. First, spatial compression. It analyzes each frame to spot distinct elements, like separating the dog from the background. Then, temporal compression. It looks across frames to eliminate redundant info. If the dog stays in the same spot for multiple frames, it merges those tokens. It's like editing a video by first tidying each shot, and then ensuring the same object isn't repeated unnecessarily across the whole clip. But how does it stack up against other methods? Researchers tested LLaVA-Scissor against techniques like VisionZip, which focuses on images, and FastV, which prefills data. The results? At lower retention rates, like keeping just 10% of the original tokens, LLaVA-Scissor outperformed the competition. Think of it as a chef who can make a gourmet meal with a tiny ingredient list, while others struggle with more. Here's what the data shows. When keeping 50% of tokens, all methods are pretty close. But when they cut it to 10%, LLaVA-Scissor shines. At 3% retention, it scores 86.8% on average, while others drop to around 80.7%. That 6.1% gap might sound small, but in AI terms it's huge. It means the model retains critical details, even when processing super lightweight data. This breakthrough isn't just about efficiency, it's about understanding. By focusing on semantic regions rather than raw pixels, LLaVA-Scissor bridges the gap between human-like comprehension and machine processing. Imagine a world where your phone can analyze a 2-hour video in seconds, or where medical AI identifies critical patterns in scans without being overwhelmed by noise. But how does it do all this? Let's peek under the hood. At its core, LLaVA-Scissor uses a clever trick called union find, a data structure that's like a digital team organizer. Imagine you're managing a group of people and want to track who's in the same team. Union find helps you. 1. Find which team someone is in. 2. Merge teams when needed. To make it lightning fast, it uses 2 hacks. Path compression, like flattening a family tree so you can find your ancestor faster next time. Union barrank, always attach smaller teams to bigger ones so the structure stays balanced. This lets the AI quickly spot patterns in video data, like figuring out which frames are connected, without checking every single one. It's like surveying a crowd by asking a few people, who's in your group, instead of interviewing everyone. The result? A system that's not just smart, but efficient, perfect for the real world where power and speed matter. And with papers like this, we're one step closer to AI that thinks, learns, and adapts like humans. So next time you watch a video, remember, behind the scenes, tools like LLaVA-Scissor are working hard to make sense of the chaos. Thanks for watching, stay curious, and keep exploring the future of AI.